Hey, what's going on, guys? Let's do this problem right here. We have this one, integral of dx over 5 minus 4x minus x square over 5 over 2. If you notice, this is not a polynomial function, and in this kind of situation we try to find the square of, we try to do the complete square for this one and then begin the question, right? So let's grab this part here. We have 5 minus 4x minus x square. I can rearrange this one in the order of the power. So this is going to be minus x square minus 4x plus 5. I can take the minus common here. So this is going to be x square plus 4x, and we have a plus 5 right here. And if you look at this, to complete the square we have to add a value, because a square plus 2ab plus b square pattern, that's what I'm trying to bring in order to factor this one, right? So first of all, like what I can do, the thing we do is we divide this one by 2 and square it, right? If this value 4, right? If I divide this one by 2, this is going to be 2 square. That's the value we are going to add. X square plus 4x plus 4. And if I add this 4, and since we have a negative sign right here, we have added a negative 4. So I had to add another positive 4. We have also 5, it's already there. But I had to, if I put negative 4, I had to put a positive 4. If I put a positive 4, I had to put a negative 4. Because we are adding value, so we have to add another value that will eliminate that one, right? So that's how we do this. Now we can find this form. This is going to be x plus, this is going to be a plus b square. This is the expansion of this one. So I can rewrite this one as x plus 2 square, because this is 2 square right here. A square plus a plus b whole square, right? And that's how we got this one right here. And this is minus, and if we add this together, this is going to be plus 9. So we can say this is 9 minus x plus 2 square. Now we can bring this one into this one. So this is going to be integral of dx over 9 minus x plus 2 whole square, and this is only for this one. Then all together we have 5 over 2. And if you look at this, 1 over 2 means square root power 5. So I can rewrite this one as dx over square root of 9 minus x plus 2 square all together power 5, right? And if you notice right here, x, the derivative on the top, derivatives, this one is on the top, so I can do the u substitution. If I pick u as x plus 2, derivative is going to be dx. Now I can write this one in terms of u. So that is going to be integral of, instead of dx, I am plugging the du. So this is going to be du over square root of 9 minus u square power 5. And now we can do the trigonometric substitution, because we have this pattern, number minus variable square. So we can bring this format. So I can take u as equal to 3, because this is 3 square, 3 sine theta. And if I find the du comes out to be derivative of this one. This is going to be cos theta, right? 3 cos theta d theta. And this is derivative of this one. And now we can write this one in terms of trigonometry, trigonometric substitution. So this is going to be du is going to be 3 cos theta d theta, 3 cos theta d theta. In the bottom we are going to have 9 minus, this is going to be 3 square sine square theta, so 9 sine square theta. Here we can take the 9 common. The first thing we try to eliminate this square root. That's the first thing we have to do. So first of all, I can take the 9 common, so this is going to be integral of 3 cos theta d theta, and we have power 5. We have to already keep that one, power 5, 3 cos theta d theta over, in the bracket, in this one I am taking the 9 common, so this is going to be 1 minus sine square theta, 1 minus sine square theta, sine square theta plus cos square theta is equal to 1. If I take the cos 1 minus sine square theta is going to be equal to cos square theta, I can pre-plug this one into this one. That's in that way I can eliminate, I can get rid of the square root, right? So that's the first thing we try to do. So 3 cos theta d theta, I can already take this 9 outside, so this is going to be 3, but we have also power right here, so we have to remember that one. So this is going to be 3 power 5 if I take this one outside. Then we have, in the square root, we are going to have cos square theta. I am plugging cos square theta instead of this. Cos square theta. Now we can completely get rid of this square root. So this is going to be 3 cos theta d theta over 3 power 5 cos theta, and this is power 5, right? Power 5, so this is going to be cos power 5 theta. Here we have 3 power 5, we can get rid of this one of these 3 because we have 3 on top here. So if we cancel these two, this is going to be 3 power 4. Let's use a different color to continue, right? So this is going to be, I can also cancel this cos theta, and this is going to be cos power 4 theta. So I can bring the 1 over 3 power 4, I cancel one of these 3, and we have left with cos power 4 d theta. Cos power 4 d theta on the bottom, I can, 1 over cos power 4 theta d theta, cos 1 over cos theta sec theta, right? So I can bring it on the top as sec theta. So 1 over 3 power 4 integral of sec power 4 theta d theta. And in this case, we have power 4 right here. So what we can do, we can separate this one into 2 parts, like 1 over 3 power 4 sec square theta sec square theta d theta. And one of the sec square theta, I can replace this one with 1 plus tan square theta. This is a trig identity. So sec square theta is equal to 1 plus tan square theta. I can replace this one because that's gonna give us another, that's gonna enable us to do another u substitution. But since we use a u already, I can use different later. So let's see how we can do this. 3 power 4 integral of sec square theta. One of them I am replacing with this one right here. 1 plus tan square theta d theta. And if I take the tan, derivative of tan is sec square theta. So I can pick up the tan as my u right here. So since we use the u already, let's pick a w. W is equal to tan theta, and derivative is going to be sec square theta d theta, right? D theta, yeah. So we have sec square theta d theta, and if you look at this, this is this value right here. So I can replace this one with w, dw, and this one with w square. So let's continue maybe with a different color. Okay, here we go. So I'm going to write everything in terms of w. 1 over, let's see, this one works. 1 over maybe red, okay, 1 over 3 power 4 integral of sec square d theta. I'm replacing with dw, so this is going to be dw. In the bracket we are going to have 1 plus tan square theta, that's going to be 1 plus w square, 1 plus w square. So we have this one right here, and let's see. Now this one is easy to find easy to do the antiderivative. Let's rewrite this as, let's bring the dw in front. So this is going to be 1 plus w square dw, and the integral of this one, 1 over 3 power 4 always remains, and then we have this one is going to be w, and this is going to be w cube over 3 plus constant. Now we have integrated this one, but we have to do the back step substitution, because we have converted theta into w, and we have converted u into theta, and we have converted x into u. Our original form is this one, right? X, all are in x. So that's what we have to try to bring back. That should be the final answer. So let's go from w to theta first. So we have substituted tan theta for w. So if I do that, it's going to be 1 over 3 power 4 tan theta plus tan cube theta over 3 plus constant. So this is in tan format. We have derived tan from where? From this one. U is equal to 3 sin theta. So u is equal to 3 sin theta. I can rearrange this one as sin theta is equal to u over 3. And let's draw a triangle right here. Right, theta right here. Sine is opposite of hypotenuse. U is opposite, 3 is hypotenuse. And in this case we need the adjacent, because tan theta is going to be opposite of adjacent, so we are going to use as adjacent. So adjacent is going to be hypotenuse square minus opposite square. I am using the Pythagorean theorem. 3 square 9 minus u square. So this is our hypotenuse. Now we can plug everything in terms of u. So this is going to be 1 over 3 power 4 instead of tan theta. Tan theta is opposite of adjacent, so that's going to be u over square root of 9 minus u square, plus I can bring the 1 over 3 to the front. This is going to be, let's continue here. So u over 9 minus u square all to the power 3, and then at the end a constant, right? Constant. It's like a little bit messy right here. Maybe I continue this one right here. Let's use a different color. Maybe let's use, yeah, the red here. Let's continue with the red. So we have brought back this one into u, but however our original function is x. Now I had to plug x plus 2 instead of u. So let's plug x plus 2 instead of u. So this is going to be 1 over 3 power 4. Instead of u I am plugging x plus 4. This is going to be x plus 2 right here. So x plus 2 over 9 minus x plus 2 square within the square root. Then we have 1 over 3 plus 1 over 3. This one right here, x plus 2 over square root of 9 minus x plus 2 square whole power 3 and at the end plus constant. So it's like a little bit messy right here. Since we don't have enough space, we can't do anything, right? So this is the final answer. This is 3 power 1 over 3 power 4 x plus 2 square root of 9 minus x plus 2 square 1 over 3 x plus 2 9 minus x plus 2 whole square and all power cube. This one all together cube because this is tan cube. We need to derive this one from tan cube plus constant, and that is the final answer. I hope you guys like this video. See you next time.